Hi all, good morning. Let's start Maths, Grade 11, Chapter 4. Chapter name is Complex Numbers and Quadratic Equation. Subtopic is Argand plane and polar representation. Learning objectives. After this session, learners will be able to define the Argand plane, represent the complex numbers on the Argand plane. Introduction to Argand plane. We already know that corresponding to each ordered pair of real numbers x, y, we get a unique point in the xy plane and vice versa with reference to a set of mutually perpendicular lines known as the x-axis and y-axis. See here, for example, this is a Argand plane x, x dash, y, y dash. Now, the complex number will be in the form of x plus iy, which correspond to this ordered pair x, y can be geometrically represented as this unique point P of x, y in the plane xy plane and vice versa. So here just we have given this some examples. For example, here this point is here x value is 2 and the y is 1. So the value of this complex number is 2 plus 1i. This value is 1 plus 2i. This value is minus 1 plus 1i. This value is minus 2 plus 0i. This one is 0 minus 3i. This one is 1 minus 2i. Definition of Argand plane. Some complex numbers such as 2 plus 4i, minus 2 plus 3i, 0 plus 1i, 2 plus 0i, minus 5, minus 2i and 1 minus 2 which correspond to the ordered pair of 2, 4, minus 2, 3, 0, 1, 2, 0, minus 5, minus 2 and 1, minus 2 respectively have been represented geometrically by the points A, B, C, D, E, F. So if we observe here, for example, first is A is 2 plus 4i, that means x value is 2 and this y value is here 4. So in this x coordinate is 2 here and this y is 4. So this is the point of the A. Similarly now here minus 2 plus 3i. So minus 2 plus 3i it will come in this second quadrant because x is negative here and y is positive. So we'll go here, x is this will be 0, minus 1, minus 2. So x is minus 2 and y is 0, 1, 2, 3. So minus 2 and 3. This is the value of B minus 2, 3. Similarly, all the points we are represented here. What is the definition of the Argand plane? The plane having a complex number assigned to each of its point is called as a complex plane or the Argand plane. So this we call it as Argand plane, where the here x-axis represent the real values and the y-axis will represent the imaginary values. Distance from the origin to the point P of x, y. Obviously, in the Argand plane, the modulus of the complex number x plus iy is equals to square root of x square plus y square is the distance between the point P x, y, and the origin. So, from the origin to this point P x, y, the distance is square root of x square plus y square. We know the distance between the 2 points is this geometrically x2 minus x1 whole square plus y2 minus y1 whole square under root. In place of x2 will substitute as this x, in place of y2 will substitute as a y, in place of x1 will substitute as 0, in place of y1 will substitute as 0. So we are getting get the distance as square root of x square plus y square. The point on the x-axis correspond to the complex numbers is in the form of a plus I0. So on the x-axis means here wherever we will take this on x-axis any point, there will not be any imaginary values. So the point will make it as this a plus I0. Similarly, the point on the y-axis correspond to the complex numbers is in the form of 0 plus IB because there are no real values here. So we will get only imaginary values on this y-axis. Thus, we will notate it as a 0 plus IB. So the x-axis and y-axis in the Argand plane are called the x-axis are the real axis and the imaginary axis. So x-axis we call it as a real axis and the y-axis we call it as a imaginary axis. Let us find mirror image of point Px, y. For example, here point Px, y is a complex number represented in this two-dimensional picture where x is a real part and y is an imaginary part. When we want to draw this imaginary or mirror image of this Px, y means obviously this x value remains the same, only this imaginary values will become this minus. So here when x wants to be the same, the positive values, and the y wants to be the negative of that one, we will come as instead of the first quadrant, will come as the fourth quadrant. So geometrically Px, y is this a point. The mirror image of Px, y is Qx, minus y. So geometrically the point x, minus y is the mirror image of the point x, y on the real axis is represented as shown in the figure. Summary. A number of the form a plus ib where a and b are real numbers is called a complex number. A is called the real part and b is called the imaginary part of complex number. Let z1 be equals to a plus ib and z2 equal to c plus id. Then z1 plus z2 is equals to a plus c plus I into b plus d. Similarly, z1 into z2 is equals to ac minus bd plus I into ad plus bc. In general, for any integer k, I power 4k will be 1, I power 4k plus 1 is equals to I power 4k plus 2 is equals to minus 1, I power 4k plus 3 is minus I. The conjugate of the complex number z is equals to a plus ib denoted by z bar is the complex number a minus ib, that is z bar is equals to a minus ib. Thank you.